Okay, we'll just get started with the topics, and if you have any doubts in the content, you can just stop me wherever you want to. Okay, so first we'll start with trigonometry. So first things first, you need to know the basics of trigonometry and how it works. So trigonometry is basically the geometry of triangles. So you're going to study about triangles and its properties. So first, we will be taking a right angle triangle mostly because the ratios will be associated with the right angle triangle. So these are the six ratios you will be doing. So first, if this is the angle theta, as you can see in the picture, this is angle theta. So for this angle theta, sine theta would be the opposite side, the ratio of the opposite side to its hypotenuse. Got it? So you can see this is an exam tip over here. You can use this. So means SOH. So sine opposite hypotenuse. So sine theta equals to opposite over hypotenuse. And ka here is CAH, which is cos for cos. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. I think these are some facts you might be knowing already. So I'm just reviewing those before we go on to the formulas and all. So then cosec. Cosec is basically the reciprocal of sine. So which is hypotenuse over the opposite side. And secant is the reciprocal of cos, which is our hypotenuse over the adjacent. And cot theta is adjacent over hypotenuse, adjacent over opposite, which is or the reciprocal of tan. Okay, simple way to remember which is for which. Cosec, you can see the third letter is S, and for sine, the first letter is S. So that means you can remember by this cosec theta is the reciprocal of sine theta. And for secant, the third letter in secant is C, and for cos, the first letter is C. So you can remember that secant is the reciprocal of cos. And then we are having cot. Cot, you can see T is the third letter, so tan will be the reciprocal of cot theta, cotangent. Okay. Any doubts here?
No, no doubt.
Okay, then we can move on. So as we saw that sine is 1 over cosec, cos is 1 over secant, tan is 1 over cot. So it's basically reciprocal. I've just written it in this form. And you need to know that tangent theta is equal to sine theta over cos theta. So how this works is, sine theta is opposite over hypotenuse. Then you divide this by adjacent. Cos theta is adjacent over hypotenuse. So when you do this division here, you will get opposite over hypotenuse times hypotenuse over adjacent. Adjacent. So hypotenuse and hypotenuse will get cancelled. You will get opposite over adjacent, which is basically tan theta. Got it? So in some questions, you will be using this formula because sometimes they give you the sine and cos, and then they ask you the tangent. So you can use this easily to find it. Any doubts before moving to graphs? I think this is the
No, no doubt. No doubt.
okay. Then we can move on. So
No
here,
doubt. No
yeah,
doubt.
okay. So for trigonometric graphs, sine. First, we will see the sine graph. How the sine graph will look like. Wait, I have made. thing in Desmos. One sec. We will visualize the graph in this app. This is called Desmos. It's a graphing calculator, so you can visualize it better. So here I've already given the graph for sine x, y is equal to sine x. So it will be basically some the sine 0 will be 0. Sine, you can see the points, the critical points over here. So sine 0 is 0, sine 90 is 1, sine 180 is 0, and sine 360 is 0. And here 270 is -1. So what happens when you give it y is equal to 2 sine x? So you can compare this. So what happens is the graph is a little bit stretched, okay, stretched up and a little bit stretched down. So basically, this two indicates the altitude or the altitude of the graph. So let me take a screenshot. So here you can see that this is 1, this altitude is 1, and this altitude is 2. Okay, so that the 2 here gives the altitude of the graph, how much it's stretched up and stretched down. Okay, and then we will be seeing 2 sine 2x. So we will compare it with this because 2 is same. The first 2 is same. So 2 sine 2x. So what does this 2 give you? This 2 here represents the period of the graph. Period as in how many times it completes a cycle in uh, in one cycle. So it's how many cycles it completes in 360 degrees. So with respect to 360, because sine and cosine, sine and cos are respect to 360 degrees. So one, if it is just sine x, we saw that the one period will finish at 360 degrees. So you need to compare this period with the 360 degrees. So if it is two periods in 360 degrees, there will be one cycle to 180 and another cycle to 180, 360. Got it? So if there is a two cycle, then you will see that one cycle finishes at 180 and another cycle starts from 180 and finishes at 360. So whenever you're going to find the number of cycles you need to draw the graph, you just do 360 divided by the period. Got it? Any doubts? If you have any doubts, just stop me. Okay, I will be moving on. Okay, so now the next one is this plus 4. What does this plus 4 indicate? This indicates basically the transition of the graph. So if it is transitioned up or transitioned down. So if there is a plus in bit after this, then it shows the upward direction, and if it's a minus, then it will be the downward direction. So here you can see that you can see that 2 sine 2x is this green graph, and purple is the 2 plus 4. So it's moved up 4 units. Okay. So like it's basic only. This is basic only. It's the transition of up and down. If it is moving up, it will be plus, and if it's moving down, it will be minus. So next we will go with cos graph. Cos graph is just the opposite of sine. It's a similar wave, but similar pattern of the wave, but it starts from 1 instead of 0. So here you can see it starts at cos 0 equals to 1. Let me use cos 0 equals to 1, and then Cos 0 equals to 1, cos 90 equals to 0, cos 180 is negative 1, cos 270 is 0, and cos 360 is 1. So these are the critical points on this graph. So again, same thing. The altitude changes, then it is stretched up and stretched down. If here, if it is 2, then it's stretched 2 times as the first graph. And then 2 cos 2x is the period, the number of cycles in 360 degrees. So if it is 2 times, then it gives the cycle for 180, and then from 180 it will go for a 360. And then we will see the transition. You can see I wrote plus 5. So it is transitioned 5 units up. So the green graph, okay, I'll show you okay, the green graph, this green graph is transitioned 5 units up. So that's what plus 5 indicates. Any doubts till sine and cos graphs? If no, we can move on to tan. Okay, considering no replies, I'll just move on to tan. So tan graph is a little bit different because tangent has a period of 180 degrees. So one cycle finishes in 180 degrees instead of 360. So here you can see the graph of tangent 2 tan x. I've written 2 tan x. Wait, no, sorry, this should be up. Yeah, y is equal to tan x. Let's see if y is equal to tan x first. So you can see here tan 0 is 0, and this 90 degrees, tan 90 will be an asymptote. Asymptote is that there is no value for that tan 90. It's just the imaginary line passing through. And this graph will be approaching that, but it won't touch that dotted line. So like if you can see, I'll just draw it. So this is tan 90. So it won't touch this dotted line, and this dotted line is known as asymptote. So whenever sketching tan graphs, you need to remember where is the asymptote, and you need to sketch that asymptote to confirm that your graph doesn't touch the asymptote, and it approaches, but it does not touch the asymptote. So then you can see that at 180 it's again 0. So that means this is one complete cycle. So uh, try 1 second. I think I lost. Share screen here. Yeah, so here you can see that 180 is 0. So when one cycle completes in this manner, so this is 1 and this is 1. So this is one cycle. So you can see this is the cycle of one of the tangent graph, and it completes at 360 as the convention is 360 for degrees. We complete with 2 cycles for tan x. So then 2 tan x, basically it is a little stretched. It is stretched 2 times. So the gradient of the 2 tan x will be greater than the tan x. And then 2 tan 2x. So you can see it's all mostly similar because the asymptote the graph will not meet the asymptote. But 2 tan 2x has an asymptote at about 45 degrees. You can see at 45 degrees the asymptote is given. So if I write y equals x equals 45, so that is the asymptote over here. So you can see it is approaching, but it won't touch. If I zoom it, it won't touch. Okay. So you can see it's not touching the asymptote. So the black line is the asymptote. X is equal to 45. Okay. Okay, the next one, we'll see the transition. So you can see the transition. If it is for plus 5 transition, the tan 0 will be at 5, 0, 5. So when you give 0 into this input, you'll get 5 as output. It's moved up 5 units. And if it is a negative or negative value, then it will be moved down the number of units it's given. So it's more or less similar. Just remember that tan graph has a period of 180 degrees. So whenever you're comparing the 2x, so this 2x, whenever you're comparing it, you will need to do it with 180. So 180 degrees divided by 2, so 90 degrees. So at 90 degrees, the this will be touching, the 0 will be touching for this graph. So okay, yeah, Ahmed, you have a doubt.
Please, I don't understand.
You don't understand what tan graph or which part?
The graph.
This graph tan, right?
Yes.
Okay, I'll explain it again once. Okay, what I have given this asymptote 90 and 1 second. I'll just okay. So what you can see, these two lines are asymptote. Do you know what's an asymptote, or do you need an explanation again? Have you understood the term asymptote?
Please explain asymptote for me.
Okay, so asymptote is basically a imaginary line. So actually, this line should be dotted, but I don't think I can make a dotted line here. Okay, so what? I'll just draw it on the chart here. Okay, so when you draw a tan graph, right, you will have two asymptotes for y is equal to tan x. So this is the general graph. So one is at 90 degrees, so 90 degrees, and one is at 270 degrees. So what does this asymptote mean is this is an imaginary line. So the graph won't touch this line unless it is drawn. So whenever you're drawing the graph, you should not touch this line because there's no value for tan 90. So tan 90 is undefinable. Okay, so this is undefined, right? You know this, right? When you punch it on your calculator, it will show you math error. So what does that mean? So tan 90 is undefined. So there's no value for tan 90. Got it? Ahmed, got it?
Yes,
You?
okay, thank you.
Yeah, and then when you draw it 180 degrees, you draw it like this without touching this line. So this dotted line, you should not touch the graph should not touch this line, and then it just moves like this. So at 360 also, you will draw it downwards without touching the 270 degrees. So tan 270 is also an asymptote, so there's no value for tan 270. And this asymptote also varies depending on this period. So if this period is 2, right? So this will move towards the left. So it will be at 45 degrees and oh, 225 degrees. Okay, so depending on this period, or the asymptote and the graph will move because when you write it, let's say tan 2 times 45, then only you get 90 degrees. So you need to make a 90 degrees to get that asymptote. So this 2 is the period, and this 45 will be the the asymptote in this case. Okay, but it's not always. But for you just remember that wherever tan 90 is coming, that will be the asymptote of that point. Okay, tan 90 and 270. So this all also gives you an undefined value. So that's why that's an asymptote. And whenever you draw the graph, it goes up towards the asymptote but does not touch the asymptote. And depending, this is the A, which is the altitude, it's stretched up and down. Depending on this A, if it is 2, it will be stretched like this. So the gradient will vary. And yeah, this C, this transitions the graph up and down. So if it's starting at 0 and this C is +1, this it will start at 1 and then move. So this x-axis will start at 1 and then you need to form, because of the transition up and transition down, this C will also make the graph go up and down. Okay, got it? So you can remember this
Okay.
by, so you can remember this A. Okay, so A goes for altitude, B goes for the period, and C is the transition of the graph. So it determines the transition if the graph is moved upwards or moved downwards. Any doubts? Or else we can go for a practice question. You can all try.
Practice.
Okay, so here's a practice question. So this is basically 1 mark, so it's easy. You just need to find the period. So period means you need to find it in respect to 360 degrees, with respect to 360 degrees. So you need to give the answer in degrees because here it is 1 by 3, right? So it's 1 by 3. You need to give it in respect to 360 degrees. And I already told you how to compare
1080.
the period. Come again?
It's 1080.
1080. Okay, so what will it be? 360 divided by 1 by 3, which is 360 times 3. Yeah, it's going to be 1080. Everyone got that? Then we can move on to the sketching the graph. And one more question based on this. If I'm going to have 2 tan x by 3 minus 1, what's the period of this equation? What will you do here?
It's gonna be 540. It's you just have to do 180 instead of
Yeah,
360.
180 divided by 1 by 3, which is 540. Everyone got it? So whenever it's a tan graph, you need to compare it with 180 degrees. And when it is a sine or a cos graph, you need to compare it 360 degrees. Okay, now you can sketch the graph. You can just draw a rough sketch. So I'll just show you how it will look like. So it shows here you can see it is -1, right? So the graph will start at 2. Okay, so since it's 2, the altitude is 2. From 0 to the starting point will be 2, and since it's -1, you need to move the graph one step down. So that means it will start at 1. Y is equal to 1. Have you understood this fact? Why it starts at 1? You want me to explain again? Anyone, if they are not getting it? Hello, can you hear me?
And
Did you understand why we started the graph from 0 at 1? on the
Yeah.
y-axis.
Yeah.
Okay. So then the graph will roughly look like this. You can just, I'm not drawing it to scale or finding the values. So it should roughly look like this. Because the for one cycle it will take 1080 degrees, right? 1080 degrees. So then for 360 degrees it will be one third of the graph will be drawn. So this part is one third and this is this the opposite side. Got it?
Get it. I get it.
Can we move on?
Yes,
I think graph system. Can we move on? I couldn't.
No, I don't get it.
You don't get it. Okay. So you know that this. Okay, I'll just minimize the screen. Okay, you know that we are starting it from one. So you're clear with this, right? Set.
Yeah.
Yeah. Okay. So what? You need to draw one third of the graph. Here you can see it. The period is at one third. So because 360 for usually this graph will be from this to 360, right? So usually for any cost graph, you will draw it like this. This is the basic graph. So like this is the basic graph. You need to just take one third of the portion. So it's about somewhere here. So this is one part, this is one part, and this is one part. So three parts you divide it equally and roughly sketch this one third. So it will be going and then touching, but it won't. You won't draw the rest of the parts. So only this part is needed for this graph. Now you got it.
Yeah.
So
Yeah.
then on the other side also. So this will be like this, and then you divide this into three sections, and only one of the section will be drawn. Got it? So this section is only drawn here and this section is only drawn here. So when you combine these two, you will get something like this. So this what is I drew and then extended. Got it, Nanik? You have any doubts?
No, no doubt.
No.
Okay. Then we will go on to identities. So there are three main identities you need to know in the IGCSE syllabus. Now, do you like feel any difficulty in remembering them, or are you fine with it? So I'll just write down those. So sine squared theta plus cos squared theta equals to 1. And there are two more with tan and secant. Okay, so I'll give you easier way to identify this. Okay, so here we have hd squared plus, so this is the basically the Pythagoras theorem I have written here. So this is the horizontal distance, this is the vertical distance, and this is the length, the RL for length, the hypotenuse basically. So whenever you find the magnitude, you use the Pythagoras theorem to find the magnitude, right, of the line. So that is basically hypotenuse. So the first thing you do is you divide this by uh, wait, you divide this whole thing by hd squared, I think. Hd squared. Yeah. So you divide it by hd squared. So what you will get? 1 plus bd squared by hd squared equals to RL squared plus hd squared. So now you can find this one is you can write this one as this, and then this vd squared by hd squared. What is that? So considering that we will take the angle here. So this is the angle theta. So vd squared plus hd squared. So that will be the tan, right? You understood this?
Yeah.
So what we did basically is we are going to divide it by hd squared for the first identity. So for the first identity we divided by hd squared and we got 1 plus tan squared and RL squared over the hd squared. So that is basically the inverse of cos, which is secant. So then this will be secant square theta. So now you have the first identity. So this is the first identity.
Pardon?
Yeah.
Oh, I thought it wasn't.
Do you understand how we are getting? Because I think remembering this, yeah, this will be given in your formula sheet also, but it's easier to understand by this method. So it's easy. I'm just telling this method so it's easier for you to understand. So everything comes from the Pythagoras theorem. Just we are finding the ratios and then comparing both the sides. So then what we do for the second identity, we divide it by VD squared. VD squared. So you will get HD squared over VD squared plus 1 equals to RL squared over VD squared. So the second identity will be HD squared over VD squared. So that is cot squared theta plus 1 equals to RL squared over VD squared. So RL is this and VD is this, which is the reciprocal of sine, which is cosecant square theta. Cosecant square theta. So you got the second identity. So this is the second identity and this is the first identity. So the third identity is this sine square plus cos square. You know how it will be forming. You use the same pattern. You divide it by RL squared. So HD squared over RL squared plus VD squared over RL squared equals to 1. So basically this is HD, this will be cos squared theta plus sine squared theta will be 1. So you get this is the third identity. Got it?
Yeah.
So these are the three main identities you will be learning for IGCSE. I think that you can also make a lot of forms from this by manipulating both the sides, but those are not needed for now. Small exercise here, you can just try this question. So 2 cot, once you have finished, you can just let me know so we can move on.
I got 19.5 or 160.5. 90.5.
I cannot hear you,
Or
Seth. I think there's a lot of background noise.
oh, okay. So
So basically, you convert this cot squared x into cos x. So
yeah,
with using the
90.
identity, and then you can then do the quadratic.
You get quadrant.
Understood? So cot squared will be cosecant 2 times cosecant squared x minus 1 minus 5 cosecant x minus 1 equals to 0. 2 cosecant squared x minus 5 cosec x, and then this becomes negative 2 and negative 1, negative 3 equals to 0. And then you can just solve the quadratic from here. So it will be in this using my calculator over here. So it will be cosecant squared cosecant x will be 3 or negative 0.5. Cosecant x is negative 0.5, and then you just find the x from here. And then make sure the range is from 0 to 180. So the answer should be between this. You can. Also another trick you can evaluate. You can like maybe use it when you're checking for your answers, the range of answers you're getting. So like here it's for 5 marks, right? So at least you need to get 4 values. So just keep in mind, but it's not sure. Okay, I'm just giving you a hypothetical way to get the number of values for the number of marks. So at least 4 values will get you the 2 marks for the answers. Okay, and then 3 marks for your steps if it's correct. So getting to this will be 1 mark, and to this will be 1 mark or 2 marks, and the answers will be 2 marks. Got it? So that's how it's mostly graded. Can we move on? I think the next is also one more practice question. Any doubts? Seth and Leonard, if you have,
It's clear. It's okay.
come again.
It's fine.
Okay. Nanik, you are also fine, right? How you know how to do from here?
Yeah, yeah. We have to run into sin x now, and you,
Yeah, yeah.
yeah, invert. It's pretty easy.
And you can also use this thing to check for your if you get 4 values or the number of values for your answers.
Yeah,
Here is another one within a domain. So the domain means this only, basically this. So the domain for this answer should be between 0 and 2 pi radians. So just remember that you can be asked for radians and degrees. Both are in part of the syllabus. So you need to be very sure when you are converting from degrees and radians in your calculator whenever you are using it. So my advice to you for the calculator when you're using it to find these, make sure it's always in degrees. Then after you find the degree values, you can easily convert it to radians using the pi by 180 formula. You can use the formula to convert it to radians because when you are using both when you're switching between both the radians and degrees on your calculator, sometimes you might miss your which mode it is on, and then sometimes on the actual exam you might make a mistake. I've made this mistake on my exam too, so I'm just telling you that it's good to keep it in degrees, and then whenever they're asking you in radians, you can just convert it by doing my calculation
I
instead
feel
of
like
just converting in the mode.
I feel like you can make mistakes in degrees also because in like differentiation or integration you cannot use degrees and
Yeah,
physics. So over there you can make mistakes if you use degree mode, which is what
yeah,
I've
but
done.
it's okay. It's maybe it's good. I'm just telling it's good to keep it in one mode for the whole test instead of changing it between both. That would also take time, and sometimes it's also error prone. It's very error prone. So because most of the answers in the calculator will come in decimal points, right? So in decimal points, you won't even know if it is degrees or in radians. Here it is 2 pi, so you can know that pi, whenever there's a pi, then it's a radian, and whenever there's a degree symbol in the it's a degrees. But in the calculator, you may not know when it is given in the decimal exact form. Maybe you can just copy this. I think we can move on. We have one more chapter to cover also, so that's going to take a little more time. Can we move on?
Yes.
Okay. Yeah, this is one of the other. This is the last part of this uh, chapter. So we will be having this proving questions frequently. So you need to use the identities and by sometimes Pythagoras theorem to find these to show that this is equal to this. So whenever this type of question, I'll usually follow this steps. So first, what I'll write it LHS, whatever the LHS is, or RHS. You can choose anything for the first part, and then you need to convert it to second. So just choose where there are more terms. So it's best to choose the side where there are more terms. So here, if there is two, and here it is one. So it's best to convert from 2 to 1 rather than from 1 to 2, because it will sometimes you might not know which identity to use when you're converting from 1 to 2. But whenever you're using it from 2 to from greater number of terms to the lesser number of terms, you can easily convert by seeing the number the terms here. So if it is sine and secant square, you need to convert both this cosec and cosec to secant and sine to find the answer. So to prove this identity. Okay, so I'll just give you a hint on how to do this. So you cross multiply over here, cross multiply, and then the denominator will be cosecant squared theta minus 1. So this is in the form of a square minus b square. And then since this is in this form, you can convert this into secant. You can convert this into the tan squared theta. I think. Yeah, it's tan squared or cot. I think it should be tan only. No, it should be cot. Sorry, it should be cot. So it should be cot squared theta, and then when you can just find it, making the others also in the same similar manner. You need to finally you need to get to the sine and secant. So these are the you can keep these as the goals to convert the LHS to RHS. Got it? Okay, let's just move on to the next topic. So now we'll be doing vectors in 2 dimensions. So this topic is it's easy but a little lengthy as to say because there's a lot of subtopics in this. So first we will be covering vector notation. So what is a vector? A vector is anything that has a direction and the magnitude, right? You agree with this? So any value that has a direction and magnitude. So that's the vector. And scalars are without direction, so there's no direction to the scalar. So you can write vectors in these two ways. You need to know both of the ways. They might in the questions they use both these ways to ask you. So just be familiar with both. So A, B, up arrow. So this up arrow shows it is a vector, and you can, this is a columnar vector form. So this is columnar vector form. Vector form. And this is the other type. So this is the algebraic form. Got it, Seth? I think he left. He has some. We'll finish this fast. Okay. It's. Are you available, or you want to continue tomorrow?
Only if you are free. If you are free, let's continue.
Let's continue. Okay. So you understood this, right? The columnar vector and the algebraic form. So these are the two forms you need to be familiar in IGCSE syllabus. So then position vectors and unit vectors. So the vector that shows the location of a point with respect to the origin is the position vector. So
You,
let's
you, do you also teach ICT?
come again. I couldn't hear you.
Do you also teach ICT?
ICT, no, bro, I didn't take that subject in my IGCSE. Sorry. Okay, we'll just continue. We'll just finish this vectors off. So the vectors that show the location of the point with respect to the origin. So this is the origin. So this is origin 0, 0. And any vector going, so let's say this is 2 and 3. So this is the unit vector. The position vector is basically the vector that compares this and this. So you can remember by this. So this 2, 3 is the position of this vector. And unit vector is the unit vector in the same direction as A. So some vector A. The unit vector is always calculated by the A divided by the magnitude of the vector. So the vector divided by the magnitude of the vector. So here if it is 2, 3, the magnitude of this will be 2 squared plus 3 squared, which is, you know how to calculate the magnitude, right? So this is how it's done. 4 plus 9, which is 13. So square root of 13 is the magnitude. So what you do is 2, 3 divided by the square root of 13. So then you can just bring it in. 2 divided by square root of 13. 3 divided by square root of 13. So this is your unit vector. So now magnitude of the vector, we just saw this. So for any vector v, a, b, the magnitude of it is calculated by this formula. So it's basically the Pythagoras theorem. So when there is 2 points, so if this is the vector, and this is a comma b, you use this formula to find the magnitude. Got it? So whenever you think of magnitude, you remember that this is a scalar form of the vector. So this is a scalar form of a vector. So basically this just shows you the magnitude of the vector and not the direction. Got it?
Okay. Yes, ma'am.
It's easy, boy. Mostly it's easy. So now these are the 4 arithmetic operations of vectors with scalars. So these are all also very basic. So when you add two vectors like this, you write x, y, and a, b. When you add them, you will get x plus a and y plus b. Subtraction is also also similar. So xy minus ab will be x minus a, y minus b. And when you multiply with a scalar quantity like 2 over here, 2, you just bring it in and then multiply both the values, x and y values. Division is also the same. Got it?
Yeah, I know of this.
Okay. So you can just practice this question. I'll send the answers also in the group, so you can just check the answers from there for all these questions. So here they're asking find the vector which has magnitude of 39 in the same direction of 12, 5, negative 5. So what you do is first you take the magnitude of this direction. So what's the magnitude of the direction? It will be 13. So square root of 12 squared plus negative 5 squared will be 13, and magnitude 39. You need to, since it's a magnitude of 39, right? So you need to compare it with this. So what you do is 39 over 3. So this is this 13, which is a scale factor. So how much you need to multiply this direction vector. So
Okay.
this is 3. So that means here the vector v will be 3 times 12 negative 5, which is 36 negative 15. So this is the answer. So this is a scaling factor. How much you need to scale the vector to get to that magnitude. Got it?
Yeah.
And this is this part B is a little more. I'll just show you the answer. So basically, what you do is you need to form two simultaneous equations for mu and this. Or okay, no, wait. For this type of question, they already gave you. So some questions they give you two parts, and then they will form a simultaneous equation. So that I think that's a different type. So here they already gave you the equation. You just substitute the values and then find these two vectors, these two values, constants here. So this is how the answer mark scheme. So we saw for the first part it's 13, 36, and so this is 1 mark, and this is 36 negative 15. So this is how you do. You see, you can see that they have formed this equation, and then once you form these two equations, you can just do the simultaneous equation and find the both the constants. So just remember, whenever there is a constant, two constants, you need to make two equations to solve for those constants. Got it? And this is another practice question. I think this is also straightforward. It's the same thing. They have given you the magnitude, they've given you the direction, and you need to write both P and Q in terms of J. So it's basically the same thing. I'll just send you these questions in the Google Drive, and then you can just practice them. I think we're running out of time.
Okay.
So
Okay.
I'll just move on to the topics. We'll just cover the topics before we finish it off. Okay, now we will move on to velocity and speed. So velocity and speed and displacement and distance. So you know that speed is the magnitude of velocity. This is because speed is the scalar form, as we saw before. Speed is the scalar form of velocity. Got it? That's why whenever you find the
Yeah.
speed from a velocity vector, you need to find the magnitude of that velocity vector. And the same with distance. Distance is a scalar form of displacement. Form of displacement. And whenever you're comparing velocity vectors and position vectors, so basically use this formula. So this formula tells you how you can convert from velocity vector to position and position to velocity. So basically, R is the displacement after TR. So you can say that this is the position vector. R is the position vector. You can say this the position vector. Whenever you want to find a position of a specific point or vectors in a vector, you use this formula. And the position vector of star. So this is the initial starting point. So mostly this will be in the origin. Sometimes they will give you the starting point, and then you need to just add the number of uh, velocity vectors to it. So V is the velocity vector A and B. So velocity vector A and B. This if this is the velocity vector and time, you just multiply the velocity and time to get that position. Position meaning the displacement. Position is the displacement. How much is the vector, the point is displaced from the origin or from the starting point. And here's a practice question. I'll just send this practice question also in the drive link. You can just practice. So I think this part is a little bit you need to get more practice, because even I struggled in this, like remembering the formula and how to use that formula in different situations. So just to get familiar with this formula, and then whenever they ask whichever, if they ask the position vector, you use the R is equal to A plus VT, and then you can switch the sides and then substitute the values and use it.
Okay.
I think we are done here. I'll send the questions in the group, and then you can just review them. Okay. You have any doubts?
Okay. Now